The next topic we're going to discuss is right triangle trigonometry. So what we can do is take a right triangle, and we know that across from our angle that we're looking at, we're going to call theta, right? Theta is just a Greek letter that represents an angle, usually. So across from that will be the opposite side. Next to it is the adjacent side, and directly across from the 90 degrees is the hypotenuse. We can then do our trigonometry. So there are 6 trigonometric functions. Sine, cosine, and tangent are the ones you're most familiar with, but then they have their reciprocal functions. So cosecant, secant, and cotangent. So we know from geometry that sine is going to be opposite over the hypotenuse, cosine is the ratio of adjacent over hypotenuse, and tangent is the opposite over adjacent. And we had even discussed in the summer packet, there's a little bit of a trick for tangent, that this is also technically sine divided by cosine. Because if you were to divide those fractions, when you do your keep, change, flip to multiply by the reciprocal, the hypotenuse will cancel out, so you get the same thing. Okay, so then we have cosecant, which is just taking sine and taking the reciprocal of that. So opposite and hypotenuse are flipping, so it's hypotenuse over the opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So these are really our reciprocal functions, and they are just taking the original trig functions that we are used to and taking the reciprocal. We're just flipping them over. All right, so let's take a few examples here. We're just going to find the exact values. Now, when I say exact, I mean I don't want to see a decimal. If pi were still in a problem, you'd keep pi in it. If it's going to be a fraction, you would keep it as a fraction. So you definitely don't want to be changing things into messy decimals. That's what we mean by exact. So we want to do the 6 trig functions for each of these triangles. If we take a look at A, we see 2 of the 3 sides are completed, but it's a right triangle, and we see the 3 and the 4. If you need the Pythagorean theorem, go ahead, but you probably know this is a 3, 4, 5 triangle. All right, so if this is the angle we're looking at, we know that we have our opposite here, our adjacent is the 3, and then our hypotenuse is the 5. So we want to find the 6 trig functions for those numbers. So let's start off with sine, cosine, and tangent, the ones we're most familiar with. So if we're going to do sine of theta, that's going to be opposite over hypotenuse. So our opposite is 4, and our hypotenuse is 5, so 4 over 5. Our cosine is adjacent over hypotenuse, so that'll be 3 over 5. And our tangent will be opposite over adjacent, so that's 4 over 3. Now, to find my reciprocal functions, I'm literally going to take the reciprocal of the answers that I already have. I don't need to do anything special. So the reciprocal of 4/5 is 5/4. The reciprocal of 3/5 is 5/3. And the reciprocal of 4/3 is 3/4. It's that easy. All right, let's take a look at B. Now, you might not know this one off the top of your head. I do see a pattern, but if you don't, you can always Pythagorean theorem here. So this would be a squared plus b squared is equal to c squared. I don't know one of the legs, but I know another one is 2, and the hypotenuse is 4. So that would be a squared plus 4 is equal to 16. Oops, 16. And then subtract, so a squared is equal to 12. And when I take the square root of that, 12 is 4 times 3. So I'll get 2 root 3. And if you haven't noticed, this is actually a 30, 60, 90 triangle. If you notice down here with the 2, the smallest side, double that and you get the hypotenuse. And then you take that same 2 and you put a radical 3 next to it, and that is your other leg. So that's that 30, 60, 90. All right, so let's find sine, cosine, and tangent, then we'll find the reciprocals. So again, here's my angle. I have my opposite, my adjacent, and my hypotenuse. So if I'm going to find sine of theta, that's opposite over hypotenuse, which is 2 over 4, but really that is 1/2. I can do the cosine of theta. That's going to be adjacent over hypotenuse, so that's 2 root 3 over 4. Again, I can simplify that. The 2 and the 4 become 1/2, so that's root 3 over 2. And then we've got tangent. So that is 2 over 2 root 3. The 2's cancel, so I get 1 over root 3, but we should rationalize this. So I'll get root 3 over 3. All right, so now I want to find cosecant, secant, and cotangent. So cosecant of theta, I'm just going to find the reciprocal. So the reciprocal of 1/2 is 2. Secant of theta, if I find the reciprocal, that's 2 over root 3, but I can fix that up a little bit. So when I multiply by root 3 over root 3, I'm going to get 2 root 3 over 3. And then cotangent. So I could take the reciprocal of the final answer, but that gives me a radical in the denominator. If I take the reciprocal of this answer right here, the 1 over root 3, then I don't have to do any rationalizing. I'm going to just get the square root of 3. Okay? All right, so we're going to fill in this table. And these are kind of the basic ones. If you notice, these are the numbers that we're used to seeing on the unit circle. So if I have 30 degrees, I know that that for radian is pi over 6. Sorry if you can hear that. It's my dog in the background. Whoops, that's a terrible right triangle. Let's do a nicer right triangle. Okay. So I've got my 30 degrees up here. My 60 degrees is down here. And this would be my 1, my 2, and my root 3. All right, so if I'm going to find the sine of 30 degrees, that's going to be opposite over hypotenuse, so that's 1/2. If I find the cosine, that's going to be root 3 over 2. And if I find the tangent, that would be 1 over root 3, which is really root 3 over 3. All right, for our 45 degrees, here's my 45, 45, 90 triangle. We know that 45 degrees is really the same thing as pi over 4. If I were to find the sine of 45, that's 1 over root 2, but that rationalizes to root 2 over 2. Cosine is the same. And my tangent would be 1 over 1, or just 1. 60 degrees, I can go back to that first triangle. So opposite would be root 3 over 2. Whoops, I missed a spot. Let's do our radian first. That's pi over 3. Okay, root 3 over 2 for sine. Cosine the adjacent over hypotenuse, so that's 1/2. And then tangent would be root 3 over 1, or just root 3. All right, so we notice the pattern here, especially with that 30 and that 60. So the 30 and the 60, if you notice the sine and the cosine for 30 and for 60, so the sine of 30 and the cosine of 60 are the same answer. We also see that the cosine of 30 and the sine of 60 are the same. And we also notice that with 45, the sine and cosine are both the same. This is not a coincidence. So this is because when 30 and 60 are added together, we notice that they add to 90 degrees, right? 30 plus 60 gives us 90. That makes them complementary angles. Just like 45 and 45 are complementary angles. 45 plus 45 is equal to 90. Okay, these are complementary angles. So in general, co-functions, what I mean by that is sine and cosine. And then we have, what else do we have? We have tangent, and we have cotangent, and we have secant, and we have cosecant. It's the exact same word. It's just the word co is put in front of it. So that makes these guys co-functions. So co-functions of complementary angles are equal. Co-functions of complementary angles are equal. So because 30 and 60 are complementary angles, their sine and their cosine are going to be the same. Because 45 and 45 are complementary angles, their sine and their cosine are going to be the same. So what that means is if I take sine of this 90 minus theta here is just a way of saying whatever the complement is to theta. Okay, so sine of 90 minus theta is going to be equal to the cosine of theta, the original angle. Cosine of 90 minus theta is going to be equal to sine of that original angle. It works the same for tangent and cotangent, and it works the same for secant and cosecant. Okay. Okay. This is going to be very useful very soon when we start to kind of deal with our messier angles. Right now, we're going to just keep to the basics that are on the unit circle that you're going to see in a minute. But as we kind of go through, these are going to come up again, and they're going to